This is Dr. Carroll, and this video is about formatted string literals in Python, otherwise known as f-strings. Now, before I get started anymore, this is available starting only in Python version 3.6 or later. String values have always had a constant value, but f-strings are evaluated in real time, and that allows us to do some cool things. Python has syntax that allows us to format how variables are converted into strings. For example, have you ever wanted to display a price or some other dollar amount and had tried something like this using round? Price, I don't know, say 123,456,789 and no cents. And then to display it, but what's it going to display? It's going to display it with just 0.0 because it's a float. And so, when I'm buying something or selling something of that price, I like to make sure that it's just right. And so formatted string literals can do that for us. So we can format a string in the following way. For example, if we have a variable main dish that is assigned the string pizza, and we could have an int variable scoops of ice cream, we can have a string like this, and it carries over to the other line. Sorry, so it looks like that. And then when we display the message, or we could even do more, we could update it to main dish be my favorite, Brazilian beans and rice, and then have the exact same formatted string and print that. It will display dinner tonight is pizza, interpreting this as the variable's value, and 3 scoops, interpreting this as the variable's value. And then I just updated main dish here. Maybe we should have upped the number of ice cream scoops as well. But that's something it can do. Furthermore, is if we had the exact same price, what we could do here is, notice I've made it an f string, and then we can say, hey, we're going to format it as a floating point number, and we're going to specify 2 decimal places, and hey, let's put in some commas too, because that's really cool. If we do that, then it's going to display it with commas separating every 3 digits, and it will display exactly 2 decimal places rounded to the second decimal place. And so that way we know that we're going to always have 2 decimal places, and it's going to look as we would fully expect if we're selling or buying something that expensive. Let's look at another example of other things you can do. Here we have score equals 1234, 1,234. And notice we can perform math right in the curly braces here, or we could either multiply, or we can do exponentiation, or there's several more things we can do, and then it will display the correct amount. And so we could do it right there. We don't have to close the string, concatenate it, open a new and concatenate that with another string. So this is another option. And so the syntax is we start with an F, either lowercase or uppercase. And then we have a string, either single ticks, double quotes, and then we have some text. And if we want to represent a value, we use curly braces. We put in a variable name there. And we could have more text, and we could do another variable name. And then if we wanted to format one of these, for example, the second one, we need a colon, and then the format specifiers. And we could have had more text besides this, and you can have as many as you can type, and so you can just keep going. So the steps are, we need to have our string literal, but put an F in front of it so it says, hey, evaluate this in runtime, and you can use lowercase or uppercase f. And then anytime you want to use a variable for its value and not those actual characters, put them in the curly braces. And then to format them, use the colon and formatting specifiers. So let's talk more about the format specifiers. So what they do is they allow the variable value to be formatted. And we've already seen this with that monstrous price there. So let's look at a whole bunch more examples here. Here we go. So this first example, we have letter num equals 9. And so what are we doing? We're just displaying it to show that it can be displayed. But notice here, if we say, hey, take this value but interpret it as a character using this as its Unicode or ASCII value, then it'll say, okay, well, what's the value? What character has the value of 89? And it is Y. And so we could interpret it that way. If we wanted to represent, for example, very large numbers, a mole, we could display a mole here. And what we can do is we can say, well, that's really big, so let's separate it with commas. Wow, that was easy, and it took care of it for us. But this big a number, usually we use scientific notation. And so we use the E format specifier for that. Notice the E here, this is 6.02 times 10 to the 23rd, often used in chemistry. So now let's talk about precision and format specifiers. So here we are displaying pi to a whole bunch of digits. But now what if we only want to specify it to one decimal place? Then we say, okay, just one value place after the period is how to interpret that. And pi then is truncated to 3.14. And we could specify others as well, 3.14. We could do 3 and 4. And now notice what happened here is it rounded. Notice as we add more digits here, it will round that last number if it needs to. And so it will do rounding for us, which is usually what we want. So that's precision. We have the colon, the period, and then a number. Now we might want to do width. So let's use that score example from before. Oh, sorry, I never did that score. Okay, so now we can specify the width for a string. So notice I have these characters just to show counting here, and notice it right justified it. If we take them off, then it's going to left justify it. But if we have a whole bunch of things going on and we need it to right justify, then we can use the :9 here to specify that. And again, we can throw in a comma if we want to separate it. And notice it still keeps it right justified, so it moved it just to the left. So, and we can go back to our pi example here, and we can say, hey, I want it to be right justified for 9 places as well. And let me show that more easily here by taking everything else out. Notice it added just one space here to be able to do that. And so we can control the width for it. Now we can also control the width for strings. And so if we have a string, for example, hello, assigned to welcome, and we use the notation a greater than sign here to say that it's right justified along those. And if you want to, you can use the format specifier, hey, interpret this as a string, but if it's already a string, it doesn't do anything. Now now we can combine these. If we have a floating point number, we can do width and precision as well. And notice we are controlling it. It's right justified. Last time we did pi, it only moved it to the right one, but we could change it however we want, and it's now still right justified. I have one more example, and this one to me is really cool. If you put a caret here, and this will work with strings or floating point numbers, what it does is it centers it, which is cool because then you don't have to like think about it. You can just say, hey, oh, you know what, let's add some more precision. It keeps it centered in the width that is specified. So that's pretty cool, I think. Way to go, Python, to make our lives a little easier, a little bit more enjoyable. I hope you enjoyed that. Thank you for watching.